is equal to 0, that is an example of one x-intercept. And if the discriminant is less than 0, that is an example of no x-intercepts or 0 x-intercepts. So remember how there was 3 scenarios? So that's why there's 3 situations here. So here's a nice big blowed up version of the notes. Same thing that I wrote, just in, notes. All right, let us do now an example. You know what? No, I'm not going to do this example. This doesn't make sense right now. I'm going to do the one that I'm going to do. Or they don't ask you? No. Yes, there we go. Example 5. All right. So here we have, for each of the following quadratics, use the discriminant to state the number of roots it will have. So I want everyone to try this right now. I'm going to give everyone a couple minutes. So if you did this, remember the discriminant is b squared minus 4ac. So what's b? Well, a is the coefficient in front of x squared. B is the coefficient in front of, your x term, and c is your constant. So b squared is going to be 5 squared minus 4 times 2 times negative 5. That's 25. If I multiply these things together, what's 5 times 4? 20. 20 times 2, 40 plus 40. And that's 65. Now 65 is bigger than 0. That's going to have 2 x-intercepts. Remember, when they're asking to state the number of roots, they're not asking you to solve for the roots. You could, but yeah. All right, let's do the second one. 3 squared. Oh no, sorry, it's not 3. What am I doing? A, B, C. So 7 squared. Remember, whenever you square anything, it becomes positive, so just don't mess that up, please. Minus 4 times 3 times 5. That's 49. Minus, what's 4 times 5? That's 20. 20 times 3. 60 minus 69. That's clearly a negative number, like negative 11 or something. So that's less than 0. So this will have no x-intercepts. And the final one. So here we have example 5. 2 solutions, no solutions, and then the final one, if you plug it in, it's equal to 0, so you'll have 1 solution. So there you go, perfect. So some of you have done this. It doesn't take that long. It's very simple. So now we're going to move on to actually finding the x-intercepts. Like, what is the value? So remember, the first step was just figuring out how many there are. But now we're going to find the exact solutions. Now, this word exact, this is going to change it up in grade 10 to a grade 11 question. Because the exact solution means we cannot have decimal answers. In grade 10, mostly you would just, hit the square root sign, square root of 11, get whatever, 3 point something, and then just write the answer. But now, when we're looking for exact solutions, you're not allowed to have decimals. So any operation that will cause you to have a decimal, you cannot do in your calculator. So another example would be like, say, 2 divided by 3. That would be a decimal, but you cannot write it. You have to write an exact solution, so the exact answer would be 2 over 3. If you write 0.67, you're wrong. If you write 0.666666, you're wrong, because that's not exact. So when it comes to grade 11 and moving forward, functions and advanced functions and university, you have to write it in proper math terminologies. So let's do that right now. we know that x is equal to negative b plus or minus okay. So what's my a value? A is 3, negative 10 is b, and c is 5. So negative b. So negative 10. That's going to be just positive 10. I'm just going to write 10. I'm not going to write negative 10. It could, but, you know, makes more sense to just write 10. All right, b squared. That's going to be 10 squared minus 4 times 3 times 5 all over 2 times 3. All right, what do I get? 10 plus or minus. That's going to be 100 minus 4 times 5 is 20, 20 times 3 is 60, so negative 60 there, over 6. Then plus or minus root 40 over 6. At this point, you need to split your equation into two separate paths. One that takes the positive path of the square root, and one that takes the negative path of the square root. So this is going to be two intercepts, right? All right, so 10 plus root 40 over 6. I need to simplify this. And if you remember correctly, we actually learned in a previous lesson how to simplify radicals. And this is what this is, a radical. Square root 40 is a radical. So we need to look for a perfect square. 1, 4, 9, 16, 25, and so on. That would evenly divide into 40. And 4 looks like something that would go. So I'm going to do 10 plus square root 4 square root 10 over 6. The same thing as 10 plus 2 root 10 over 6. And the same thing on this side. It's going to be 10, except, it's a minus sign. But the numbers don't change. The minus sign is there. Can I simplify 10 further? Well, can 10 divided by 4? No. Can 10 divided by 9? No. So, and any number that's bigger than 10, obviously, you can't divide by a bigger number and get a even factor. So it has to be 4, 9, or 1. 1 doesn't do anything. So this is our final answer. The only thing I would do to simplify is to simplify a common factor between the top. This becomes 5 plus root 10 over 6. And what did I do? I divided 10 and 2 by 2. I factored out a 2. So the 10 divided by 2 becomes a 5, and 2 divided by 2 just becomes a 1. And 1 times root 10 is just root 10. Same thing here. I factor out a 2. This becomes 5 minus root 10 over 6. And the final step is to now factor out a common factor between the top and bottom, the numerator and denominator. And I know that I can factor out a 2 from the top and bottom, so the final answer becomes 5 plus root 10 over 3, or 5 minus root 10 over 3. That's the answer. So from now on, you cannot simplify further if the question is asking for exact solutions. If they don't care and they're just asking for a solution, then you just do what you would normally do and just in your calculator do 5 plus square root 10 divided by 3 and write the decimal answer. Yeah, so that's that. Let's take a look at the answer. Example 1. See if I did it right. Excuse me. And what do you know? I did it right. I'm not going to go over another